live very soon. I always do this. It's probably already started, but I have to wait until it gives me this final thing on Zoom. Okay. All righty. Welcome to BIMS Dives. I'm Dr. Tiara Moore, founder and CEO of Black and Marine Science. And today, we're diving into ocean and atmosphere with Dr. Vernon Morris. The conversation will be moderated by our Chief Relations Officer, Kris Howard, and our Chief Management Officer, Alex Troutman. Dr. Morris joined Arizona State University as professor of chemistry and environmental sciences and director of the School of Mathematical and Natural Sciences at the New College of Interdisciplinary Arts and Sciences in July 2020. Prior to coming to ASU, Dr. Morris was a professor of chemistry and atmospheric sciences at Howard University. All right, HBCU. While at Howard, Dr. Morris founded the Atmospheric Sciences Program, which is the first PhD granting program of its kind at any minority-serving institution. And we are so excited to hear from him today. I'm also excited to see, as you can see, we have Vietman Barber here today who will be doing ASL interpretation. So please put any questions you have in the YouTube chat, and we will answer a few live as we have time. Kris, I'll go ahead and pass it to you.
Thanks, Tiara. So like Tiara said, Vernon here works a lot with that in atmospheric science. So our first question here for you today is, can you define atmospheric science and its link to the ocean environment?
Let me unmute. So first, thanks for the invitation and opportunity to join Black Marine Science. I follow you on Twitter. I've followed you for a while, and so it's good to be here, see some faces. Atmospheric science is pretty broad, and so generally speaking, atmospheric sciences covers disciplines like meteorology, climate science, air pollution, meteorology, air pollution, chemistry, satellite meteorology and satellite remote sensing technologies, especially of the atmosphere, but also of the surface of the planet or the ocean, because you've got to extract the atmospheric sort of signal out of those signals, the total signal, so that you can get information about the land surface, or get information about the ocean surface, or get information about the ocean composition near the surface. So it's an interdisciplinary combination of disciplines that allows us to understand processes in the atmosphere on multiple timescales. And it applies to all planets, so it's not restricted to the Earth. Any planetary body that has accumulated a gaseous envelope around it has an atmosphere, and therefore there's some chemistry or physics or dynamics associated with that gaseous envelope. And climate, you said, and how does it relate to the marine environment, I think? Is that?
Yeah.
A lot of ways. I think we'll probably delve into a couple of specific ways as we go along, but certainly climate is one. The ocean drives climate, and the atmosphere couples to the ocean in a variety of different ways. And that those feedbacks sort of accelerate or amplify climate effects in different parts of the globe near the land surface, as well as in the upper atmosphere, actually. But there's also nutrient deposition into the ocean from the atmosphere. There's the water cycle. And so how do we drive moisture from the water bodies or the oceans into the atmosphere, form clouds, distribute clouds across the globe, and then bring back fresh water to the land surfaces. So it's they're innately coupled. They cannot, we decouple them in models, but in fact, in the material world, they are strongly coupled.
And that's something I feel like we hear from a lot of our speakers, how just marine science and the ocean environment, such a interdisciplinary thing. And that's something we try to push also, that, you can be into marine science, not exactly have to get in the water and be on a boat. There's so many other things, you can do to
Absolutely.
do this type of science.
Yeah, nothing wrong with getting on a boat, though. Even if you're a dry side guy like me, it's fun to be on the water.
Dr. Morris, thank you for being here again. I'll start with question 2. Can you please tell us about your background and what fascinates you about the sciences?
Well, background, I went to Morehouse College undergrad, so HBCU undergrad. I went to Georgia Tech, and at Morehouse College, I majored in chemistry and mathematics. And then for my PhD, I went to Georgia Tech and majored in geophysical sciences. At the time, the same department has now changed its name to Earth and Atmospheric Sciences. And I did that primarily because of my research mentors in undergrad, who was doing research in the chemistry department, developing models and doing laboratory experiments to look at chemical processes in the stratospheric ozone, polar stratospheric clouds that were contributing to the stratospheric ozone hole. And I liked that work a lot. I was trying to figure out whether to go into molecular physics or chemical physics, or go into atmospheric science. And there were 2 very different factors that influenced that. One was the birth of my daughter. I was a single parent, and my sisters were in Atlanta at the time, and that was sort of my support system. And leaving to go to the places that I was accepted, Ohio State, primarily Ohio State, Berkeley, and Harvard, were too far away for me to maintain that support system. So that was one factor. And then the other, I really felt that atmospheric sciences, its interdisciplinary aspects, satisfied my curiosity, more addressed sort of the way I think about the world in a more holistic way, and not just doing one sort of thing and one reaction, but not connecting that to the larger Earth system. Because the thing that fascinated me about what I studied then and what I study now, is this connection between the invisible. I look at atmospheric particulate, things that you can't see unless there's a whole bunch of them there, and then it scatters light. But how chemical and physical processes on objects that are too small to see influence climate, things that we feel globally, or weather, things that we feel locally, but they're being driven by processes that we can't even see with a microscope. And so how does that happen? Can we measure it? Can we model it? Was, and remains very exciting to me. I can talk about that all day, so I'll stop before I get going. But yeah, that's it. And so I, after my PhD, I went to Sicily and worked at the Advanced Study Institute on interstellar chemistry. Georgia Tech was, I was the first African-American to graduate with a PhD from the program at Georgia Tech. And which means it was really isolating. And at the time I was at Georgia Tech, the first African-American got his PhD in chemistry. It was a study mate of mine. The first African-American got their PhD in mechanical engineering. The first African woman got their PhD in physics. So Georgia Tech was producing a lot of undergraduate degrees, but not a lot of Black people at the PhD level. And so the graduate programs were very hostile, is probably the best word I can use. And so by the time I finished, I just wanted to leave. I wanted to get as far away as I could, and there was an opportunity in Sicily, so I took it. And I did not even walk for graduation. I left town as soon as they said, okay, your thesis is okay. I said, peace. and I was in Sicily, which was really fun, stressful, because I did have to leave my daughter behind for several, which was going to be an extended period of time. It turned out to be, I truncated it to come back, actually. But I left, worked on cosmochemistry, came back, took a job at Lawrence Livermore. It turned out that Lawrence Livermore was even more isolating than my graduate program at Georgia Tech. I sat in a cubicle and programmed. And then I took the UC presidential postdoc at UC Davis, a University of California presidential postdoc program, and returned to civilization. Ended up having 2 more daughters, and then returned to the East Coast to Howard University, and was there for several years and started some programs there, and left last year during the pandemic to pick up a new job here at ASU. So that's sort of the arc of my trajectory, my career trajectory so far. Hopefully it continues for a little while longer.
Yeah, and that's a great segue into our next question here. Some of the programs you started. You were the founding director of Howard University's Atmospheric Sciences program. Can you tell us a little bit more about the program and why you felt the need to start that program there?
Well, yeah, Kris, that was, a lot of that was because of the experiences I had in graduate school. And as excited as I was about the science and as fun as it was to do the research, the community and social aspects of atmospheric sciences were, as I said, very hostile within the graduate program and at Georgia Tech, but even going to national meetings and things like that, it was tiring being the only African-American in the room. And it was tiring having to distinguish yourself from the janitorial staff or the service staff. Yeah, I'm here to give a talk. I'm not here to do whatever you park the car or whatever you think I'm here to do. And there wasn't very much momentum in the field to change. There was one other African-American who graduated the year I graduated from Michigan. I found out from NSF that there was one other Black person. And so I looked him up. It turned out to be a guy I still know to this day, and we worked together, Greg Jenkins. But was talking to him, and we were like, you know, this is not the way it should be. And so we actually both ended up at Howard University. And basically starting the program was a way that we could take into our own hands, in some sense, the destiny of the field, that there was going to be more diversity, even if we had to create it ourselves. And so that's where it came from. We were able, but you know, the development of the program rested on the recruitment of several other African-American faculty and eventually white and Latino faculty to Howard to support the development and evolution of that program. But yeah, it came out of just not wanting to be alone in the field. It's too much. I think it's too much fun, and I think, and it seemed like that was the only way to sort of catalyze change. And
a little bit more on that, how do you think the program is doing there? Do you see that they're some of the participants in the program, they're happy to see that something like this is there for them? Since you said you had your experience, can you see that in the students that are in this program now, that they have that safe space? Yeah, good point. I think so. I think it was a successful program in the sense that it produced over 60% of the Black PhDs in atmospheric sciences during its first 10 years in the nation. Like more than, like close to 2 out of every 3 Black atmospheric scientists graduated from that program. And so we were definitely, I think that's an indicator of the
space that we were able to create, that people were able to be successful. It was sustained success. It's obviously still going. It's probably still one of the most diverse atmospheric sciences programs nationally. And I think it's got a really strong set of alumni who are out in various parts of the atmospheric sciences community doing some really wonderful things. But I think we did create a space that would enable success where there was very little or few spaces like that before. There's been some more programs that have started since then. North Carolina A&T has a PhD program in atmospheric science now. I think Hampton still has their program in atmospheric, PhD program in atmospheric science. Over the last couple of years, there's been a very visceral response, I think, to the public murders of African Americans in our society, in our national landscape. And so I think a lot of geoscience programs, a lot of academic programs have tried to step up to the plate where they were, frankly, not doing very much before then. And so I think that's a positive sign. I hope it's sustained and it's meaningful on multi-decadal scales, but I think that program helped. We actually started a couple other programs to help support the PhD program. And I think the suite of programs that we put together really created a strong and safe space for atmospheric sciences.
That's great there. And that number of the 2/3 of the those Black scientists that are coming from that program is extremely impressive. And
it's impressive, and then it's also a statement about what everybody else is doing.
That's a good point.
Yeah. So I mean, I want to give credit to everyone who was affiliated with the program, the students. They did a fantastic job. It turned out that was about 15 or 16 students. So the rest of the 50 PhD granting programs in the United States produced less than 15 students in that decade of color.
Wow.
So that's that.
It's definitely more work that can be done there than
much more work.
So it's clear that though you are an advocate for making opportunities in the geosciences available for all people. So another one of the programs you're involved with is the National Weather Camp. So can you tell us a little bit about that, please?
So a lot of the programs that I've started, the inspiration for those programs has been either a negative experience of mine or a lack, something that I wish had been there, but it wasn't. And so, in looking at this sort of a purposeful attempt to change what the future looks like, where I saw gaps, we had a critical mass of really energetic faculty who we'd sit down and brainstorm about what if we had a program like this, or what if we tried that, or et cetera. So the weather camp came out of basically some feedback that we got that said that African Americans really weren't interested in weather. That you have a program, but your program's going to fizzle because Black people, brown people, they don't really care about meteorology or earth sciences. They're more interested in other fields. And so we felt differently. I felt very strongly that if there are opportunities that are connected to career opportunities, and it's clear that if you study this thing, yes, there are jobs that you may never have heard about, and you don't have to study specifically meteorology in order to be in atmospheric sciences or have a lucrative career in atmospheric science. If you can show that, then you can expand the number of people who ultimately go into that spectrum of careers. And so careers was called the Careers Camp, and I don't remember fully the acronym. I think it was Channeling Atmospheric Research into Experiential ERS. I forget it was a creative acronym, careers. If you Google it, I think it's out there somewhere. But what we wanted to do was not just have this camp, and the original camp was at Howard. We bring high school students onto campus for 2 weeks, and they had short classes for some of the day. They did demonstrations. They had tours to different research facilities on campus and off campus, but we brought in professionals from different sectors of the atmospheric science, weather, and climate communities, from industry, from federal government, from academics, obviously, from nonprofit, all kinds of different things, not just research, but people who were doing marketing and product development and broadcasting and all of these different areas, and tried to show that actually, no matter what you want to major in, there's space in atmospheric sciences industry for you. And so we started at Howard, and then we brought on a camp in Puerto Rico. The camps were getting filled real fast, so we said, well, when we expand the camps in such a way that nationally there can be hubs of these camps. And so we had a camp in Jackson. We ran 4 camps: camp in Jackson, camp in El Paso, Texas, camp in Puerto Rico, camp in Washington, D.C. And the camps are free. That was the other thing. We said, look, if you charge for the camps, then basically you eliminate people who either can't afford to travel to where the camp is set up, or the finder's fee. And you're basically creating sort of a class distinction, because I couldn't have afforded, again, if I'm looking at what my experience was, I could not have afforded to go to a camp in Washington, D.C. for 2 weeks in any summer while I was in high school. Not financially possible. So if I want to reach the broadest spectrum, camps got to be free. And what we actually did was we paid people to come to the camps, because most people, not only is it cost prohibitive, but you're probably working during the summer. And so for you to go someplace for 2 weeks, you're losing pay. And so what we did was we said we would pay the equivalent of the minimum wage for 2 full weeks while you're at the camp. So if you had a job, you don't lose any pay. So you are coming, net zero cost to you to learn about opportunities that you can convert into a career down the line. And you get to stay on a college campus, get an immersive experience, and you start broadening your professional network, because the weather service director would come, there were directors of NASA who would come, there was leaders in industry. And so we encourage students, collect the cards, eventually it became, connect to people on LinkedIn and stay in contact. And the camps expanded from Howard to those 4 to actually 13. At the largest point, we had 13 camps nationwide, 2 in Puerto Rico, 11 nationally, all free, all targeted at marginalized identities. And so we preferenced, it wasn't exclusive, but we preferenced and encouraged applications from Latinx, Native American, Asian Pacific Islander, Native Hawaiian, African American. And we found funders from industry, and that actually created this. We ran the camps 18 years. And so that created a pipeline that to this day, when I go to the American Meteorological Society meeting or the AGU meeting, people are coming up to me who are postdocs at NCAR, National Center for Atmospheric Research, who are in my weather camp, or faculty members who are in my weather camp, PhD, got their PhD, are now like doing the same job I'm doing, but they actually started off in the weather camp. And so, that was unexpected. That's when we started that. We started that as a camp in Howard, just trying to create some opportunities, or in Washington, D.C., or Washington, D.C., Maryland, Virginia. So that was a big surprise. That remains a huge surprise to me, how much impact an idea like that had. And I think that was one of the ideas we literally sketched out on a napkin, at lunchtime. What if we did this, this way?
Sounds great. Then that piece you said too about the camp being free. I mean, that's and then providing the housing for them on the 2 weeks on campus and everything is really big. Because I feel that's something we hear a lot for accessibility in these types of camps and things that, although a student may love to do it, but the family just can't simply afford to get the kid there.
Yeah. And man, yeah, it was free. You get there. Well, the only thing we didn't cover was you got to get to the place, but we covered all the housing, all the food, provided the stipend.
Agreed.
Should I be looking at the chat?
I actually have a question for you from the chat. So someone asked, why are the ocean and atmosphere decoupled in models?
That's for computational. The short answer is for computational expediency. It's tough to, the older models compartmentalize components of the Earth system. So you had land surface models, you had atmospheric models, you had ocean models. And it was difficult enough to get these global scale models to work in a consistent way without having to worry about, coupling across the different spatial scales that things happen and the different temporal scales that things happen. So the ocean works on much longer, it evolves on much longer time scales typically than the atmosphere does. The land surface evolves on really long time scales. And so just to couple the processes that exchange energy and mass and matter between those, biological material between those, not to mention the human aspect of the coupling is very complex. And so in order for people to really understand processes in each of those different components of the Earth system, they separated them completely. That's certainly not physically how the world operates. But models are not truth. They're tools that we use to try to understand our physical reality. And even our physical reality is how we interpret, and try to chase after truth, because, our total conception is not everything, even as we pursue it as scientists. So the models are always going to be less than complete. And the current models are doing much better in coupling ocean and atmosphere, ocean, land, and atmosphere. They're not fully coupled to ecosystems. And that's a current drive right now, is to have a fully coupled land, earth, atmosphere, ecosystem model. But they have started putting in anthropogenic sort of forcing factors as cities get larger, smaller, agricultural practices change. So, land usage, urbanization, land cover changes, they're starting to make the models more and more complex, but that means that you need much more computational power, speed, memory, et cetera. And so that has to the technology has to keep up with the science in some of those cases. And it lags a little bit.
Thank you for that. That segues us into the next question is, the ocean and the atmosphere work together in producing climate. Climate change is a current hot topic. Can you tell our audience the importance of climate change and how they can be a part of the solutions for climate change?
Yeah, I mean, it's literally going to be a hot topic for some time. We have driven the we've pushed the Earth system to its limits.
Right.
And so we are going to see the impacts of that for decades, if not centuries. And it's a good question, but the framing of the question is a little bit problematic. So there are things we can do as individuals, absolutely. But the things that we do as individuals are not going to stem the direction of climate change at this point, because it is larger scale systemic processes and systems, systems of imperialism, systems of capitalism, that have driven the Earth system to where it is right now. And so I can use more efficient light bulbs. I can stop eating meat. I can, only use organic solvents. There are things that I can do as an individual, or a person can do as an individual, to reduce my individual carbon footprint. And those are worth considering and evaluating. Reducing the amount of plastics that we use. But again, we've put so much plastic in the environment, we're going to be eating, plastic is going to be part of our DNA literally, because any seafood, you're ingesting plastic, right? That is what it is. They're finding plastic, nanoparticles at the top of the troposphere, at the top of our breathable atmosphere. So we're breathing it, we're eating it, it's in our water. We can stop using it, but it's in our, it's too late for that to have the global scale impacts. We actually have to change the way that nation states are operating for climate change to be something that's addressed fully. And so I'd say what you do at the individual level is certainly try to reduce your carbon footprint, but moreover, advocate for political change, advocate for policy change that will actually change the direction of how we are operating as a nation that is destroying the climate. Which is probably not the happy answer on late Friday, but
Right. Well, someone else from the audience asked, could you unpack your question about, could you unpack your question about anthropogenic, or your comment about anthropogenic practices?
Oh, so what I mean by anthropogenic is basically human-induced processes. So transportation industry, any sort of emissions that come from the consumption of fossil fuels or lead to the changing of the land surface or involve extraction of resources from the solid earth or ocean at this point, because now we're gonna, drill in the oceans, we're gonna drill under the ice caps, we're gonna extract minerals from the ocean floor. And these all have huge climate costs, but they're not gonna happen naturally. They happen largely because we have systems of governance and economic systems and systems of exploitation that say we've got to consume, and we got to consume no matter what, and we'll push the effects down the road. And so that's the Anthropocene. That is the current era of the Earth system that we are in, is dominated by human choices and human impact on the Earth system. Now, it largely affects how we live, our quality of life, and the biodiversity of things that live on shorter timescales. The Earth will certainly survive beyond humans if we extinguish ourselves and drive the climate to the extremes. But that's the framework of humans is the perspective of the living world of humans. So I'm answering it with respect to that. There are elements of the Earth system that don't care about humans. I'm not, but unfortunately, they're susceptible to our decisions. Hopefully that answers the question. If I didn't answer the question, certainly ping me and I'll go in whatever direction you take the question.
All right, so we're going to switch gears here kind of a little bit. Could you tell us about the research you and your team have done on the Ronald H. Brown, studying your long-range transport and the influence the atmospheric particles emitted from the Saharan desert on a regional and atmospheric in the ocean?
Okay, yeah, so yeah, this sort of goes back to my point that even though I study the atmosphere, I still love the ocean. So one of the major projects I've been involved in and led over the last couple of decades now is a project to look at global mineral dust transport. And so why look at mineral dust? Well, you've got these deserts that are distributed around the Earth that have dust storms that are not just local, but they liberate literally tons of mass, push that into the atmosphere, and then that circulates around the globe. And the role that atmospheric particulate play have very strong climate forcing. They can have both positive forcing effects, heating the atmosphere system effectively, or they can have cooling effects, depending on where they are, how they chemically evolve, and when they actually go into the atmosphere. They can seed clouds and create more cloud cover, but they can also reduce precipitation, accelerate drought. They bring nutrients to the oceans, they bring nutrients to the Amazon rainforests, but they can also drive pathogen transport between hemispheres. And so there's, deserts that are far away in our mind's eye. Conceptually, the Saharan desert is far away from the United States. Why should we care about it? However, it's continuously injecting particles into the atmosphere that affect the biodiversity of the oceans, which mean our food chain and our food supplies and our love of seafood is actually impacted by those deserts. They can influence tropical cyclone development. And as we're moving into a climate era where we may have much larger and much more intense hurricanes, slower moving hurricanes, that interaction, whether it intensifies or it completely quells those systems, is important. But we are still at a nascent stage of understanding what that coupling actually is. Certainly for food security, the pathogen transport's interesting, are of note, as well as human health, because it affects air quality along the eastern seaboard, but the larger the storms are, they can affect air quality all the way across the United States. So we knew some of this or suspected some of this about 20 years ago when we started, but we were really more focused on impacts in the Caribbean. And so when we began to study what was understood, most of the experiments were just setting up monitors in the Caribbean and measuring when a dust storm happened. But as a chemist, or at least a person with a chemical background, my question was, okay, you can measure that it gets there, but you kind of knew that already. Is it changing as it moves around? Because if it's changing chemically as it moves around, then that's going to affect the radiative properties of the atmosphere. That's going to change the chemistry of the atmosphere. And that has both short-term or weather types of impacts, as well as long-term climate impacts. And we can't measure that if we only measure, along different stations in the Caribbean. So we wrote a proposal to set up an experiment on a ship, the Ron Brown, which is a Class 1 research vessel, to study the ocean properties, the atmospheric properties, and also calibrate satellite sensors during Saharan dust storms. And that would give us this comprehensive set of information that did not exist at the time that would allow us to answer huge variety of questions. If we could just generate a data set that said when you have a large, heavy dust storm, this is how the atmosphere changes, this is how much deposition, this is what happens to the ocean, this is how much gets across. A light dust storm, dust storms from different regions of the Sahara are different chemically. So their nutrient deposition patterns are very different. Their microbiological profiles are different. So your pathogen transport is different. The impacts on humans can vary a lot depending on the microbial signatures on the dust, much more so than how much dust you get over. And so that was something that we didn't expect, but we sort of teased out of the data. And then the satellite calibration actually paid for a lot of it because we invest billions into instrumentation that we put up in space. But we never actually test it over remote parts of the globe where you might get interferences that you couldn't simulate in the lab. So the only way that you can validate that and actually bring value to that investment is you have to go out into these remote spaces over the ocean and calibrate the satellite as it passes over with real measurements. And so that was another aspect of the cruises that continues actually to pay for a lot of the cruises as we continue to put sensors in space. So so that's sort of the broad view. We go out at different times a year. This is the first year that I am not going out. I'm very sad about it. Not seeing a team out, but we'll be back out next year. But we team with typically we team with a group of scientists from NOAA and quite often NASA, but always NOAA, that service some of the moored array in the tropical Atlantic. So we collect dust from those buoys out there, as well as samples, measure chemistry and composition of the atmosphere and the particles in the atmosphere throughout the transects. So, and it's to me, it's fun. It's great to be out in the water. It's exciting to take the measurements, bring them back, see their impact. We've been able to improve a lot of the satellite retrievals with our data. We've improved the hurricane models for NOAA. We've improved the global climate models with our data. So it's been highly rewarding. And again, it was something that it was higher risk than what we thought it was at the time. But looking back, it was pretty risky at the time we started, when there was a lot less connectivity out over the ocean. As you went out of the ocean, you got one email in the morning and one email at night. So you couldn't constantly monitor where the dust storm was or anything like we do now. It was fortunately, we were successful that first time, because if we'd not been successful the first time, they would not have invested in a black PI of the Class 1 research vessel of the U.S. again if I fail. So I didn't think about that either at the time. I was just like, well, I got a good idea. Let's do this.
And I might have missed it, but about how long are these research cruises?
They vary. The first one was only about 27 days. And so the shortest ones may be on the order of 24, 25 days. The longest ones are a little over 2 months, 65 days, 67 days out there. But it depends on our trajectory, because sometimes most of the time we're sailing from someplace in the Caribbean across to the Canary Islands, or roughly to the Canary Islands. We do a transect down the coastline of West Africa, and then we return. But occasionally we will, return to Brazil and go back out, or go down to South Africa. And so those longer cruise tracks add to the time. But the typical one is on the order of 30 days.
So that's quite a bit of time out there.
It's a little bit, it's a little bit of, but you got to chase a dust storm. You got to get out there, wait for the dust storm is going to come off. You got to sort of chase it back. And so it allows us enough time to do the type of characterization that we need. And then there's the oceanographic teams a lot of times are deploying buoys or retrieving buoys, re-outfitting. And so there's sort of 3 teams aboard every cruise. There's one oceanographic team that's doing CTD casts and doing sort of the physical, some of the chemical oceanography. There's the buoy team that's deploying and servicing the buoys, the moored array that's out there, and there's the atmospheric science team, which is doing the dust. And so we try to utilize the ship completely, but all of us have to sort of get our science done. So that sort of extends the time a little bit as well.
Thank you for that. Your comment about being a Black man failing, it kind of resonated with me, because many times I am either the only Black person or one or few, not just Black, but a person of color in the office. So I feel like the representation of all like Black people are on me in the office to not screw up or messing up, because it'll mess up things for people down the line for me. So I feel like I'm always doing like 110% going above to make sure like the next person has a good reputation to come into.
Yeah, that's it's that pressure is there regardless of how you deal with it, unfortunately. And so, yeah, I'm aware of it, but I can respond to it differently at this stage of my career, because I can create spaces for more African Americans or more BIPOC or whomever, because I have greater authority at this stage. But certainly when I was a grad student, even a junior faculty, there was just a lot of pressure in the back of my mind. Is like, okay, if this fails, it could be the last time I get a chance to do this. And that means it's the last chance, there's going to be some gaps before the next person gets a chance. And so fortunately, we've been successful in a number of the things that we tried to do, but it's an unfortunate aspect of being in a field that's so marginalized or marginalizing.
Yeah, thank you for that. Going back to the chat box, how concerned should we be about rising ocean levels, and should we worry about cities permanently flooding?
Well, the ocean levels are rising. So that is a fact. But the ocean levels are not rising and nobody's doing anything about it. But what's happening is that the responses to ocean level rise are largely political processes. And so the folks who have the properties and the money to protect them will have the engineering technologies and sort of terraforming programs to protect those spaces. It will still flood because the ocean is still going to rise. And so what's going to happen is that there's going to be differential effects along coastlines on the people who are either politically disenfranchised or just don't have the political clout to protect their spaces. And a great example is New Orleans, right? New Orleans, they're having a huge sediment redistribution going on right now. It's pretty much going to bury a community of color in water, but it will protect certain parts of New Orleans. And so if someone said, okay, oh my goodness, we have to move New Orleans back off the coast, there's going to be, the rich are going to say, nah, it's going to be fine. We got this engineering we're going to do. We're going to move this sediment out of the Mississippi, and we're going to preserve New Orleans. But there will be some communities that are no longer able to survive where they are and will have to be displaced. And it's like there are islands in the Pacific that are going underwater, and you've got to move people. Why? Not because there's not an engineering solution. They don't have the money for the engineering solution. So unfortunately, we have not reached a point of climate equity at this stage. And so there will be coastal regions that flood, but when you look at those regions, quite possibly they're going to be racialized, and quite definitely they will be those regions that have the least political will and agency. Another, probably not the happiest, got any happy questions? No, I'm gonna be real.
It's all good. Keeping it real. That's what we need sometimes, to keep it real.
I'm gonna be real. This is why we need more Black climate scientists, more Native American, indigenous climate scientists, more, Asian Pacific, Hawaiian. The communities that we need to, the communities that are most vulnerable, the spaces that are most vulnerable geographically are among the least represented in the field. And so as we come up with solutions, as we visualize the future, people sitting in the room are going to reflect on their futures, on their experiences, on the places that they came from. And so implementation of those solutions are going to have many times unintended effects. They're not looking and saying, I want to flood them and not over here. But they are saying, I don't want to flood over here, so what do I got to do to protect that space? And if there's no one from this space in the conversation saying, wait a minute, that's no good, we got to do it a different way, then it goes the way that many of our solutions go, which compromise the integrity of lifestyle, lifespan, life quality of racialized and poorer people.
Exactly. I had a kind of similar situation. Last year, I was doing a new certification for environmental education. And one of the projects was we as a group had to create a city around a wetland. So we all broke up into different groups and we were putting our wetland, our city around, and it was like, oh, we're gonna put houses here. We'll make sure we have a park. And then it got down to like the trash services, trash plant, and someone was like, let's throw it over here because we don't want that in our neighborhood. And I was like, well, what about the people who live in that neighborhood? They don't want it there, but they can't find it. So it was just open up another door for people who have more money than me or don't look like me to think like, oh, we never thought about it like that. Because it's out of sight, out of mind. When it's out of mind, it's in someone else's neighborhood. Like in my neighborhood, there's a like a fuel storage area that's right next to my neighborhood. So it's just like the people who can't afford to fight these environmental racism have to just deal with it, while people who can't afford it can ship it down to the lower person. It's just another way, I guess, that the world or environmental racism is not only like political, but also how much money you have.
And sometimes it's bargained into the community. They say, no, this is going to bring jobs. Don't you want jobs? You got double-digit employment. You let us put this here. This is going to take care of that. And so people are forced to make trade-offs,
right,
that have health and lifespan implications, but they also have economic implications. But exactly. Those are the choices that they're given politically, and so it can be made complex. There's certainly multiple layers to it, but I think at the onset we don't have we're not following an inclusive approach to problem solving. And so that means, since you weren't, it's like if you leave the room in a organization, they volunteer the guy who left the room, right? You weren't in the room to defend yourself, so you get that end of the stick. And that's happening in climate and environmental decisions a lot.
Right, exactly. Another question is, how can we reach climate equity?
That's a bottomless question there. I think a little at a time. I don't know. That's climate equity is like, how do you end racism, or how do you get social justice? It is a constant battle. It cannot be separated from our economic and political systems, and or preservation of wealth systems. And so again, it goes down to policy changes that are put in place that hold institutions accountable for how we manage waste, how we manage energy consumption, how we manage growth around cities and distribution and people's rights to a clean environment and access to a clean environment. One of the things that is a sticking point for me is that in the United States, a citizen has no right to clean water. You purchase your right to clean water, right? And so fundamentally, there is an element, a resource of the Earth system. 2/3 of your body is water. 2/3 of the planet is covered by water. You have no right to a clean drop of that. That doesn't actually make sense to me as not as even as a scientist, just as a person. Like 70% of everything that I can see is made up of this thing that is all around me, and I need it to survive. And I'm not guaranteed that it's clean. I got to pay for it. I think we could do better than that, but that takes political will at this stage. And it's the same thing about air. Polluted air is killing, I believe the current numbers are 12 million people a year globally. That's more than any disease. Every year. And the number's going up. And so we have to have a greater will politically to change what our current mode of operation, because we're accepting this, and some of it we're accepting because we don't know, it's not broadcast that way. But, in marine science, how much biodiversity are we losing year over year? And we know that's going to have cascading effects on multiple types of systems, not just ecosystems, but on, human systems. But we're still going in the same direction. And so there are individual dimensions of that, certainly, but it's really about changing systems of power, decision-making systems, accountability systems, and ultimately political systems.
So we're getting towards the end of our time here, so we're going to skip to our last question. So just in closing, what advice do you have for any future scientists looking to get into the field? And then what advice?
I don't know if I froze or Kris froze. Okay.
Have for those that are already in the field, that may be experiencing some burnout, or I'm back now.
Okay, yeah, you're back now. So I think it was experience for people interested in the field and people in experience, and advice for folks in the field who might be experiencing burnout. Is that? Yes. Okay.
Yeah. That's the question.
One, I think the field is huge opportunities. So if there's any interest in any aspect of atmospheric science or earth system science, geoscience, I say pursue it. I think there's huge opportunities. It's in need of intellectual diversity that can only come from, I think, more emerging scholars with different backgrounds than what the field looks like right now. And I think there are better networks. I mean, something like this would have been huge for me when I was in grad school, right? I mean, the only way that you can connect across all the different grad programs being given the small numbers in those programs is social media, kind of. I mean, that's what allows you to find that community, find support systems, find other types of mentors, find about history. it was really tough, many years ago when I was a boy. It was, you didn't know how many people had gone through. It's like, who did this before me? I don't, they didn't really know. And how could you connect to some of the folks who had gone through and gotten their PhDs? I think I'm still trying to figure out how many Black PhDs in atmospheric sciences were there before I got mine. But there weren't that many. There was less than 20. And so I'm still trying to find out, okay, I know the first, I know the second, I think I know the third. I know some folks who were like in the probably 9, 10, and then there's just these gaps, But if there had been social media, you can connect all those dots, find out what the experiences are. And so to your other question, I think resources like this can, where you can tell your stories, vent, curse out, your advisor and your program, or, having outlets with people who I think value your experience and affirm your experience, value like where you came from, who you are. That's probably the thing that saves most racialized individuals in these fields where there's very few, is that not that you had one mentor who drug you through. Sometimes that could happen, but most of the time you've got this group of people, you've got this community that somehow you found or you developed intentionally. And I think there's a lot more opportunities to develop that intentionally, through social media groups, through affinity groups. There's a number of professional societies that are paying more attention to this as well. But you've got to have a support system. You can't do it alone. Like if you're feeling burned out, you're probably trying to do too much alone. And there's, like, you're justified in being burned out, right? Like, that's a real thing. You got every right to feel that way, but it should not just extend through like, I'm turning it in. You got to find that community that helps rejuvenate you or take that time away, whether it's family or the church or, like I said, social media groups, professional societies, or just friends. You don't want to, that's a dangerous place. It's dangerous physically and it's dangerous, psychologically. And a number of people don't survive that. So it's a real good question. It's a real experience. And it's people that will get you through that, like real people.
I think you made the perfect mic drop. If you're feeling burnt out, that means you're doing too much. So stop doing too much. Find a community that supports you. If you are a Black marine scientist, definitely check us out. Visit our website, bims.org, and really find this space for you, because we are here for you. Thanks so much, Dr. Morris, for just giving us an hour. I just love the beauty of talking about race and science, how we flow in between those, our outreach, all the things that we do in an hour conversation. And this literally our task. we can't get around it. But it was just such a joy to hear you. And so, thanks so much for everybody tuning in. Of course, mark your calendars. We have BIMS Week 2 coming up November 28th through December 4th, where we got our start. We'll have workshops, panels, all types of events going on for that whole week. And of course, we'll catch you next week for our BIMS